All right. The first thing I want to talk about is one of the key concepts of geometry and higher level math. My student who said you're in pre-cal, it's crazy how often formulas that you start doing in other math subjects end up going back to the Pythagorean theorem.
Yes.
Yeah, crazy amount of algebra 2 stuff is just Pythagorean theorem in disguise, okay? All right, so you've heard about the Pythagorean theorem, everybody. A squared plus b squared equals c squared. You've probably heard it. I'm going to try to teach you some things that you may not know about it. Yeah? A squared plus b squared equals c squared. Anybody know which civilization is known for first? Not really. They're the first ones who wrote it down, so they
Greek.
get to claim it.
The
Who?
Greek.
Yeah, the Greeks. And here's a rule about the Greeks. So the Greeks were the first ones to formalize this. Pretty much most civilizations throughout time have discovered the Pythagorean theorem. Yeah? And they've had different ways of doing it, but the Greeks were the first ones to write a formal proof for it. And we call it the Pythagorean theorem, right? Um, Pythagoras was the guy who wrote it down. So he wrote a proof on it. And if the Greeks are involved in it, what form of mathematics are the Greeks known for? Anyone know? What kind?
Geometry.
They are geometry. More specifically about geometry, pictures, yes? They were incredibly good at geometry. The amount of math that they were doing just using geometry was pretty amazing. In fact, they taught all of algebra strictly through geometry. So, if the Greeks were involved, it was talking about geometry. So when you see this formula, this is actually a picture of something, what it's saying. And I want coaches and students, I don't want you to ever lose fact. Don't ever lose a sense of what Pythagorean theorem is really saying. It's talking about areas, okay? Let me give you an example. Okay, what is the Pythagorean theorem? Well, you have three sides, right? You have an A, a B, and a C side, and the C side is always across from the 90. Yeah? This A side and this B side can be flip-flopped. It doesn't matter which one. What do we call the A and B side? Somebody who knows it already? What do you call A and B?
Legs.
These are
Legs.
called the
Legs.
legs, and this is the
Legs.
hypotenuse, right?
Yes,
All right, it's the
hypotenuse.
hypotenuse. All right, A and B can be flip-flopped, so it doesn't matter which one you call A and which one you call B. They can be flip-flopped, the legs. Okay, so if you hear A squared plus B squared equals C squared, let me explain to you what's going on. When they say A squared, the word you hear that's geometry is square. That's what they're actually saying in Pythagorean theorem. Take this side and turn it into a square. So now it would be A by A, right? A by A would make an area of A squared. Now, what does that mean? Well, it's made up of, if it's an area, it's made up of tiles, right? Some amount of tiles, whatever it is, okay? B squared means take this side and turn it into a square. So it'll be B by B. That's literally what the formula is saying. B squared means turn it into a square. So take that side and make it into a square. And so, this will have some amount of tiles, right? That's B squared. I want you to get this stuck in your head, right? This shaded area, the number of tiles it takes to make that, what are they saying? What's Pythagorean theorem saying? People who are brand new, take the square, figure out how many squares in that, figure out how many squares in that. What did the Greeks figure out, somebody?
The number of tiles in the square A and square B add up to the number of tiles in square C.
Bingo bongo. That's completely true. You take the tiles, right? It's not the best square, right? Take the tiles. If you take these tiles and you add them together, right? Add up those two tiles together, they will always completely fill, right? This one completely. These will completely fill up inside of there. That is a fact of mathematics. I have seen probably 50 different proofs of why that is true. It's really not that hard to prove. There's lots of ways to prove it to yourself, but that's all Pythagorean theorem is saying. It's just saying, let me summarize this for you. Anybody can learn this. Area plus area equals hypotenuse area, right? Area plus area equals total area. Or tiles plus tiles equals tiles in the big square. That's it. In fact, there's a great little, and I don't do these very often. There's a great little video on this Pythagorean theorem with water. Yeah, there it is. All right. So this simple, fast, and simple, but this really visualizes what the heck's going on. Yeah. So they took this water wheel, right? Got the two areas, filled them with water, emptied it, right? What do you notice? Those volumes are acting like an area, right? As long as they all have the same, um, but it completely fills up that square, yes? So that's all Pythagorean theorem is saying. Area plus area equals area. Once you get that down, it's most of the stuff kind of is obvious after that. Yeah. So there is that. All right. So that's Pythagorean theorem. So let's. I know some of you probably know a lot about this already, and I will get to something that you probably don't know. But right now we're doing this for them. Yeah. So um, you can start doing this with triangles, right? All right. So say this side is 3 and this side is 4, and they ask you what this side is. Yeah? They ask you what this side is. Okay. I'm going to teach you the mathy way to do it later, but right now we're just going to do it with common sense. Okay. If I took this side, Arush, if I took this side, you ready? If I took this side and I turned it into a square,
Yeah,
what would the area of that square be?
9.
So this would be 9 tiles. Yeah? All right.
Right.
And if I took this side, what would I notice?
It would be 16 tiles.
All right. And so I could go and say 9 plus 16 is,
25.
which means that this one has to have 25 tiles. And then you can work your way backwards, right? If it's 25 tiles to make, then you can square root it to get the side length, which would be what in this case?
5.
5. Okay. So we're going to keep track of these. These are called Pythagorean triples, okay? These are numbers that work, okay? 3, 4, 5 works. Yeah? Those are numbers that will make a right triangle. Yeah, so there's one, 3, 4, 5. Okay? All right, let's change it again. And this is not the scale, right? Let's say this is 5. Let's do 6 and 10, and I ask what this is. Okay? Okay, so this is the first thing I'll usually do with somebody is I'll put this problem here and I'll see if they're completely lost, because I'll do something like this. So let's see, Anahita, I'm about to do something. When you see a mistake, let me know, okay? So take this side, you there?
Yeah.
Take the side, turn it into a square. So that's 6 by 6 is 36 tiles, yeah?
Yeah.
Take this side, turn it into a square. It's 10 by 10, so that's 100 tiles, right? And so you would do 36 plus 100 equals
No,
100.
no,
Good.
that's
What's
wrong.
wrong?
You have to do 100 minus 36.
Because the legs plus the legs
Okay.
are equal to
Okay. And that's where you can always check to see if somebody's completely lost, because they'll start adding these. Yes. If you work with a ding dong who doesn't understand anything, it doesn't make any sense that you would add these and these. No, these plus these add up to the big one, right? So, like what you were saying, yes. So you're trying, if that's 100, right? If that's 100, come on. If that's 100, you don't do 100 plus 36, that's dog water, yes? You do 100 minus 36, which is
64.
64. So there's 64 tiles here. And then, Anahita, what do you do with that 64?
You square root it, so you get 8.
8 by 8. Okay. So there's another triple, the 6, 8, 10. But in fact, that is not a new triple. It's actually the other triple in disguise. Do you guys see something here? What do you guys notice?
3 times
3
2
times
is
2
4
is
times
6,
8.
4
4
times
times
2 is
10.
8, 5
Yeah,
times
this is just, so what we call this is actually just a dilation. This is a dilation of the 3, 4, 5. Okay? And you can tell if it's 3, 4, 5 is called a primitive primitive triple, okay? This is called a primitive triple. What is a primitive triple? It's whole numbers that cannot be divided by anything. 3, 4, and 5, the only number you can divide 3, 4, and 5 by is 1. 6, 8, and 10 is not a primitive triple because you can divide them all by 2. And if you divide them all by 2, you get 3, 4, 5. And in fact, you can make new triples by understanding that. You can take a triple that you already know, yeah, 3, 4, 5, and if you double it, you get 6, 8, 10. If you tripled it, you get 9, 12, 15. That's not a primitive triple. Let's see, Andre, why is 9, 12, 15 not a primitive triple? It is a triple, but it's not a primitive triple. Do you know why?
Is it because the a squared plus b squared equals c squared doesn't work on it?
Oh, that's a good, okay, I'm glad you said that. So let's see if that's true. So let's do it, yeah? And then we'll come back to it. All right, so let's say this is 9, we're saying this is 12, and we're saying this is 15. Let's see if it works. So take a square and make it 9 by 9. What's its area?
It's 81.
Good, this is 81. Take this and make it into a square. What's 12 squared?
It's 144.
Okay, so what do we do with these two groups? What do we do with these two?
You would add them together.
All right, so 144 plus 81 is what?
It's like 225.
Well, guess what
So
15
that's
squared
15
is?
squared. Oh, so it does
Ah,
work.
it does work. In fact, I knew it worked because this is just, notice what just happened here. This is just the 3, 4, 5 being multiplied by 3. Does that make sense?
Yeah.
So I can make new ones. So make me another one. What if I multiplied everything by 4? What would it be?
It would be
12.
12 and 16 and 20.
That's right. And that's just the 12, 16, 20 is just the 3, 4, 5 in disguise. So guys, use that to your advantage, okay?
Oh, so it's not the primitive triple because it's like just it's kind of the
It's
same but a larger version.
It is. It's called a dilation. In fact, it's not a primitive triple because these can all be divided by 4. Yes, 3, 4, 5 is a primitive triple because the only thing you can divide them all by is 1. Does that make sense?
Yeah.
Okay, cool. All right, Andrew, you there?
Yeah.
All right, so I can use that idea of a dilation to my advantage, right? Because I can start using it instead of having to do all the math each time. If I said this is 15, right? And I said this is 20, and I asked you what this is, what I don't want you to do is sit there and turn these into squares and say, well, that's 225 and that's 400. There's a faster way to do this, yeah? So 15, 20, what? Any ideas?
25.
Okay,
25.
explain. No, go ahead. You explain though, Andrew.
Because it's just a dilation of 3, 4, 5.
Right, this is just 3, 4, 5 being multiplied by what? Being multiplied by what? Stay on the mic, please.
By
You don't have to.
5.
Yeah, by 5. In fact, as soon as I see, coaches, this is the way I teach it. As soon as I see 5, 15, 20, I ask myself, what can I divide them by? And I say, ooh, 3, 4. Oh, this must have been 5. It's a 3, 4, 5, which means this is times 5, so 25. Okay, I'm not joking. Most of the time on the test, if you understand that concept and once you learn your basic triples, once you understand that concept, it will open up how fast you can do the Pythagorean theorem. Okay. Okay. So any questions there on that? Okay. So our first triple that we really need to know is 3, 4, 5. All right. The next one. What if I said this side is 5 and this side is 12? Let's go to the next person. Arnav. Arnav, you there? All right.
Yeah.
Do you know this triple? Do you happen to know this triple?
Yeah, I know most of the triples. It's
Cool.
5,
What is
12,
this one?
13.
All right, so 5, 12, 13. If that side is 5 and that side is 12, this side is 13. We can check it. 5 by 5 is 25. 12 by 12 is 144. 144 plus 25 is 196, which is 13 squared. Okay? It does work. Oh, wait, did I make that? Oh, not 196. What did I just do? Help me out, somebody. What
It's
is 144?
It's
That's
one.
bad. That's 14.
169.
Yeah, 169. Sorry, 169. Yeah? The 5, 12, 13. Okay. So there's our second triple that we should know. And remember, we can do things like we can double it and make the 10, 24, 26, right? You can triple it, you can quadruple it. That's another primitive triple. It's a primitive triple because the only number you can divide it all by is 1. Okay? All right, so there's another triple we should know, 5, 12, 13. Yeah? The next one, 7. Let's see, who's next? Carly, you there? Carly, do you know a triple? Do you know your triples? I'm curious.
I know some of my triples, but not all
All
of my
right. Do you
triples.
know 7 something? There's one that starts with 7.
No, I don't.
All right. Someone help her out. 7 what?
7, 24, 25.
All right. So let's stop there for a minute. Who's my high schooler here? Who's my high schooler?
I'm going into high school.
Yeah, yeah. Well, you've done pre-cal, so surely you've seen Pythagorean Theorem a ton, right? All right. Have you ever,
Yes.
do you know a lot of your triples? How many of your triples do you know?
Um,
Like, do you know the next one? 9?
I don't remember many of them since we mostly
All
work
right.
with
And in
variations of
fact,
it.
yeah, in fact, Matthew, I don't know many of them. What I do know is I know this pattern. Okay? So everybody, let's look at this real quick. There is a pattern going on. Now listen, it's real easy to look for a pattern going down. I don't want you to look for a pattern going down. I want you to look for patterns going across. Okay? Now, let me stop real quick. Everybody's mic is off for a minute. If I have taught you this, or if somebody else has taught you this along the way, I don't want you ruining the fun for everybody else. Let them discover it for themselves. So if you know the patterns and how to generate them, you can keep generate these forever. You can make 9, you can make 11, you can make 13, you can make 15. There is numbers forever. So usually,
Is it
if oh, hold on
9?
1 second. Hold on. Usually, about 50% of the time, someone will figure out the pattern by themselves. Yeah? What do you think the next one is? Go ahead.
Is it 9, 25, 26?
It's not 9, 25, 26. No. All right, so let's go. So
Um,
there's no wrong answers right now. And listen, if you've done this before, I don't want you to ruin it for people, okay? Don't ruin their fun for them to discover this. I am Megan, you there?
Yes.
Megan, I am amazed of how many math teachers don't know this, and they should, because if you knew your triples on the 8th grade STAR test, you don't even need to know Pythagorean theorem if you just knew your triples, because 99% of the time the test is just about the triples. So if
I
you can
think I
find a way to memorize, if you can find a way to memorize your triples, you can not even have to mess with Pythagorean theorem most of the time. Yeah?
I
So,
found it.
all right, what do you think this one is?
9, 40, 41.
All right, that's true. How many people know what the pattern is yet? Let's hear thumbs up. What's going on? Put a thumbs up if you think you know. Andrew and Arnav? And don't get on the internet and Google it. That's a loser play, okay? We're trying to figure this out for ourselves. Yeah? Okay, so what do we notice? I'd rather have honesty than like what Nayland is saying. What do you guys notice? What are some patterns you see going across? Give me
Uh,
some ideas. People who are still learning it, who haven't figured it out
B
yet.
and C are like one different.
Okay, so that's important. These are one apart, yes? They're one apart. These are one apart.
That's
Yeah?
between A and B.
All right, these are one in part. Wait, say what were you gonna
And
say?
then
Somebody was gonna say something? All right, what else? Go ahead.
wait. So for A, you add 2, so it goes 3, 5, 7, 9.
Yeah, okay, so be careful with that. I don't want, there is patterns going down, but I don't even want to look at the pattern going down because it's not gonna help us. because to get the next one, I don't want to have to know what the 9 one was to get the next one. So I want to know, if I gave you 11, could you do this even if you didn't know the ones before it? And the answer is yes. You do know that these two numbers are going to be 1 apart, right? So these two numbers are going to be 1 apart. So that helps me, but I don't know what two numbers. Anybody? And if you've seen it before, be quiet, okay? Anybody? There's a
Can I take a
relationship going on.
guess?
Say it again, Sebastian.
Can I take a guess?
Yes, go for it.
60 and 61?
60 and 61 is correct. 60 and 61 is correct. All right. How did you get 60 and 61, Sebastian?
Okay, now I'm looking at the pattern going down, and I see that 4 and 5 to 12 and 13 is plus 8. And then
Okay,
12 and
cool. But
15.
but I'll tell you what, Sebastian, there's a better relationship going on that doesn't require you to look at the pattern up and down. Anyone see it yet? You can speak up now. All right, Drew, what do you see? Oh, your mic's not working, bud.
I think I got it.
All right, what do you think?
So for 5, 12, and 13, you do 5 times 2 is 10, plus that number 2, you get 12. Then for 7, you do 7 times 3 is 21, plus that number 3, you get 24. Then for 9, you do
Okay, that does work. There's some algebra behind it, but it's simpler than that. That's cool though. That actually does work. I've seen people say that before, but it's simpler than that. Way simpler than that. Come on, we're at the 50% now. Anybody? All right, I'm going to open it up to everybody now. Anybody know it? There is a pattern. Oh, come on. I don't want to have to do the next little thing to give it away. No one? Going once, going twice. All right, I'm about to give you a hint. You ready for the hint? Here's a hint. There's my hint. How about
Oh,
now?
if you add those two
Um,
numbers and you take the
All right,
square
hold on,
root,
hold on,
you'll get
hold on, hold on.
the
Wait,
you'll
stop,
get
stop,
A.
stop, stop, stop. Time out. Who was first? Arush, was it you first or Matthew?
Yeah.
All right, what
is
do you see, Arush?
If you add B and C and you square root it, you'll get A.
All right, 4 plus 5 is 9. 12 plus 13 is 25. 24 plus 25 is 49. 40 plus 41 is 81. 60 plus 61 is 121. Look at those numbers in relation to this. Thumbs up if that makes sense. Can you see the pattern now? Okay, so going back to my high schooler, I don't know my triples. I know the pattern and I can make as many triples as I want. Just one thumbs up, Nayland, not multiples. It spams the screen. Yeah, that's all that's happening. Okay, so here we go. Go ahead, question. Anybody have a question right now?
But what if the first number is an even number?
That's a great question, Arnav, and we're going to get there in a few minutes. Yeah, we'll get there in a few minutes. Hold on to that question. That's a great question. All right, so go ahead. See if you can figure out 13 and 15. And let's see, Carly. Is your mic working, Carly?
Yes.
Okay, cool. Can you figure out, you think you can figure out what the 13 has to be?
So 13 squared is 369.
169.
No, you said 316.
Yeah, 169. Okay, so what do I know about these two numbers? Give me some information. I know they have to be 1 apart and they have to add to 169. What two numbers are 1 apart that add to 169?
I can't think of. The only number that comes to mind is 84 and 85.
That's right. It is 84 and 85. Guys, and if you grabbed a calculator and you did, I don't want you to lose this. If you did 13 squared plus 84 squared, you would get 85 squared. It would work. Yes? So that does work. That's correct. Good job. All right, Kaysen, what about 15? Kason, mic working? Uh-oh. Wait, Kason, are you there? If your mic's not working, which is fine, can you get in the group chat and say something, please?
Oh, sorry, I was gone. What was the question?
No, I don't think you're paying attention right now, correct? It's okay if you're not, but just let me know.
No,
Yeah?
I was like, I went to the bathroom for a second.
Oh, well, I'm going to skip.
Oh,
Hey, guys, if you have to go AFK, just get on the group chat and say AFK. That way I won't call on you and just say when you're back. Yeah? That makes sense?
okay.
All right, cool. All right, Drew, is your mic working now or no?
Can you hear me?
Yeah, there we go. We fixed it.
Okay.
What is the 15 going to be? 15 what? What do you think?
So 15, 124 and 125. Or no,
Okay, how did
12,
that's
112 and 113.
112, 113, 112. Now, how did you come up with those numbers? Explain, because I bet you there's probably 5 or 6 people who don't understand how you got that so quick.
So 15 squared is 225. So I just got like 224 and divided it by 2, and then that's
Uh-huh.
112, and then the other 112 I just added 1, and which made
There you go.
113.
So you see what he's doing, guys? That's a perfect way to do it. So he just divides this by 2, but he calls it 224 because it's easier to divide. You get 112, and then he just adds 1 to it, 113. Okay, now what's cool about this is that this keeps going on forever. So how many Pythagorean triples do you think there are in the universe? How many?
Infinity.
Infinite.
Right. This, in fact, way more than infinity because you can take any triple that you know. Remember, let's not forget this. You can take a triple that you know, the 15, 112, 113, and you can double it 30, 224, 226. And that's a new triple that does work. There's an infinite amount of these. Okay? Okay, so let's summarize this. I'm going to clear this up now because you need to write these down. Okay? All right. Primitive triples, right? 3, 4, 5, 5, 12, 13, 7, 24, 25, 9, 40, 41, 11. What was this one?
60, 61.
61.
60, 61. Okay, those are the ones that I would definitely memorize, okay? All right. There's a couple others that you may not recognize. There's one called the 8, 15, 17 that pops up all the time, okay? And that one happens all the time. And people have a hard time, like, where does that come from? Well, Mr. Gillespie, these are 2 apart. Is there something going on there? And the answer is yes. Who is my
Maybe.
question who said, hold on one quick. Who is my question who said even numbers? Arnav, yeah? All right,
Yeah.
Arnav. So let's follow this same pattern, but let's start with 4.
Okay.
Okay, let's just take the same rule. These 2 numbers have to add to 16, and they have to be 1 apart. What would they be?
4, 3, 5.
Wait, 3 and 5 don't add to 16. See?
Oh.
And that's the 3, 4, 5 just scrambled. We're trying to do what if the smallest side was 4, not if one of the sides was 4. Anybody?
7 and
What would
9.
it?
A
Well,
decimal.
7 and 9 don't work because they're not 1
It has to
apart.
be a decimal.
They're going to have to be decimals. Good. So what would the decimals be?
7.5 and 8.5.
7.5 and 8.5.
7.5, 8.5. Well, let's see. Does that work? I don't know. Let's see. 4 squared plus 7.5 squared, does that equal 8.5 squared? Well, let's grab a calculator and see. Yeah?
It does.
Yeah, it does, but I want to show it to everybody else too. So, yeah. All right. So what did we say? We said, what was our numbers? 4 squared plus 7.5 squared. Oh, come on. Come on. 4 squared plus 7.5 squared is 72.25, 8.5 squared, 72.25. It is a triple. Okay, so we just got a new triple, right? The 4, 7.5, 8.5. We do not call this a primitive triple. Why is it not a primitive triple? Anybody know why?
Because
Because it
they're not
Rob,
whole numbers.
Because we can
they're not
multiply.
whole number.
We
They're not
can.
whole number.
Yeah, we can multiply half to 8, 15, and 17, and then we
What
would
if
get 4.
we could turn this into a triple by doubling it? Because if we double this, we get 8, double it, 15, 17. Oh, Mr. Gillespie, that's the one right here. That's where the 8, 15, 17 came from. The 8, 15, 17 came from the dilation of the 4, 7.5, 8.5, right? So you can start filling in the gaps if you want. That's what the 4 is. You can fill in the gap for 6. You can fill in the gap for 8, and it keeps working. We don't tend to learn those, but those, that's another one. 8, 15, 17, you should know. Yeah? Okay, those are triples you should know. And I'll tell you right now, if you know usually these, about 90% of the time, it's one of those on the test. You just have to be able to spot it. Yeah? So it's one of those. Let me give you a sheet out real quick. I'm curious, how many people in here already knew that pattern? How many people already knew that pattern? Okay, that's crazy to me if you think about it, because we've got some really smart people in this room who are good at stuff. Wait, who's my thumbs up who already knew the pattern? Shreya, you already knew the pattern?
Yes.
Cool, nice job. That's awesome. Who taught it to you?
I didn't exactly learn it from this mainly. Um I mostly just use. Okay, how do I explain? I didn't learn it from a coach.
Well, so, uh, yeah, Matthew, what you just said. Yeah, I have a feeling you're giving yourself more credit. This usually has to be taught to you by someone who's figured it out or has learned it from someone else. You have a job now, everybody. You have a job to make sure you go in, other people that you know knows these. So I'm going to show you something real quick here. I don't, these are my flashcards that I use on my team. Yeah, I gave, if you took some of my classes last week, I gave you a copy of some of these. These are the ones that Evelyn has to learn all of them. But let's find, here, wait. Oh, I can't find it that way. Okay, here's the triples, yeah? Right there. That's a flashcard on my team, yeah? Okay, so there's one here that doesn't follow those. We got the 3, 4, 5, the 5, 12, 13, the 7, 24, 25, the 8, 15, 7, the 9, 40, 41, the 20, 21, 29. That's a weird one that pops up every once in a while. I don't think I know why the 20, 21, 29 works. I'm wondering if it has some variation of like times 4 of some decimal or something. I don't know why that one works. So, but that's another one you should know, 20, 21, 29. Okay. And there's also one other one for my people who've already taken geometry. There's also the x root 2. That actually does work too. Any number in that form, like 2,
Oh, wait,
2.
is that for isosceles right triangles?
That's for isosceles right. That's correct. And we're going to talk about those later today or maybe tomorrow. Yeah. Okay. So there's our Pythagorean triples. Yeah. Guys, you got to know these. If you know these,
There,
you can fly through Pythagorean theorem. Yeah.
there,
Questions so far? Go ahead.